Hello U6 and welcome to the hexagon honeycomb problem. Now throughout this we're going to see how this pattern progresses and what formula is behind this pattern. Now first thing I want you to do is grab your red pencil if you have one. If you don't have these two colours, grab two different colours, green, orange, purple, red, I don't mind, as long as you have two different colours. If you're with me, I want you to use your red pencil to count all the sides. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's great. We've identified that there are 11 sides when we put two hexagons joined together. That's great. Now let's have a look at number 3. Excuse me, let me get my pencil. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, we've identified that there's 15. Fantastic. Now, as you can see just from these two, the number progresses by 4 as a hexagon is added. But what I really want you to do is identify where the sides are being shared. So I'll get my black pencil here, and I will highlight here that that is where two sides meet, okay? And then over here, we identify that this side and these two sides meet. And now we can see another pattern growing here. We can see that one side is being shared when we look at two hexagons, and we see an increase of 2 extra sides being shared when we look at the third one. Now, what we want to identify is if that will be the same when we look at the fourth one. Okay, so we're going to get our pencil. We're going to count the sides together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Great. So as we can see with the fourth one, there is an increase of 4 again of total sides. Now let's check again with our black pencil on how many sides are shared. 1, 2, 3, 4, 5. Now that's interesting. The number of shared sides is increased by 2 again. So not only are we identifying that the pattern is growing by 4 each time, but the number of sides that are shared are also growing by 2. So there's 2 different patterns going on, and that really does determine the total outcome. Now that we have found our pattern for the first 3, we're now going to identify how we can transfer this information into a table. Now, the reasons why a table is so important is because it identifies how 3 different things can work in continuity. So we have the number of hexagons, which is at the top. So we've got up to 5 here. The number of sides and the number of shared sides. Okay, so for one hexagon, I identified that there are 6 sides. Okay, no sides are shared, so the outcome is 6. If we were to look at 2 hexagons, we found out up here that there are 11, and one of the sides were shared. So what I'd do, I'd put in 11, because that's the number of sides, and 1, because that's how many sides were shared. Okay, now that we've found out the first 2, we're now going to have a look at the third one, okay? So for the third pattern, which is 3 hexagons put together, we found there were 15 sides, okay? So we'd put down 15 sides. We found that within this one, we found there were 3 different sides that were put together, okay? So we write the number 3, okay? See how there's a growing pattern here? From 1, we've noticed that there is a 2 shared side increase, and for our sides in general, there's an increase of 4. So 4 from 11, 11, 15, okay? For number 4, let's have a look at that. We found out there are 19 sides altogether. Easy, let's write that in. What do we notice? We notice there's an increase of 4 still. That's fantastic, okay? We also need to see how many sides were shared again. All right, black identifies that there are 5. There are 5, so we put in the number of shared sides, which was 5. And now we can see that the increase of 2 is still happening. This is fantastic. And now we're looking at 5. Now this is the thing, because we have a table, we don't really need to draw how many sides we see. So we don't need to put lines to each side because this table is going to help us get there. So we know that there are 19 sides for number 4. All we have to do is add 4 to 19. So 20, 21, 22, 23. So 23 sides. And all we have to do is add 2 to the number of shared sides because that's the common trend we're seeing. And that would mean that this is 7. Okay. So the last part of this lesson I wanted you to try and identify is if there is a formula within this pattern. Can we use a formula to help inform us if we were to look at a bigger number of shared hexagons? So if we're looking at 100 hexagons, could we use a certain formula to help us get there without having to count every single side? Because that would take a long time. Now the formula I came up with is this one right here. Now the N stands for the number of hexagons times S. Now the S stands for the number of sides. Now with this, we have to try and pretend that none of these are connected, okay? So we're going to split these two up. They do not touch at all. So how I would write this formula is the number of sides times, the number of hexagons times the sides equals, now in this case, 2 hexagons times 6, because the number of sides in a hexagon is 6, okay? Hexagons always have 6 sides, nothing else. So 2 times 6 equals 12. Now, what I want to do is find out how this fits in, okay? So what I'd do, I'd go 12, because that's the answer we got before. 12, take away 1, because 1 is the number of shared sides there would be if we were to put these two back together. That will then equal to our answer of 11, okay? Now, there you go. That's how it can be done. Now, if we were to look at a number beyond 5, let's say 6, this is how I would do it. So we have the number of hexagons times the sides, okay, which equals to 6. All right, so I'd do 6 hexagons times 6, okay? So we have 6 hexagons times 6, the number of sides in a hexagon, and that equals to 36. 6 times 6 is 36. Remember that, okay? Now what I'd do, I would go 36, because that's the answer we got, take away the number of sides that were shared, okay? Now how you could do this is by grabbing your concrete materials and counting only the sides that are shared, okay? This will give you the answer. Or in this case, I know that for our 5th set of hexagons, we knew that there were 7 sides that were shared. And we can tell that by looking at our table, the progression is 2 as a hexagon is added. So for number 6, I'm going to estimate, just from the findings I found out before, that this has to be 9. So I would put in 9, and I would find that the answer is 27. And you'll find that by using this formula, you'll also identify that the pattern itself, so the number of sides that are increased is 4, because 4 plus 23 is 27. So this validates your answer. And there's a step-by-step on how to complete this activity. Now, I know it's very complex and it has a lot in it, but it's all about you using about your working mathematical skills to So there you go, you 6. There's a step-by-step tutorial on how to do the hexagon honeycomb problem. Now, I know it is complex, but this is designed for you to use your working mathematical components of reasoning, problem solving, and communicating. A pattern is more than just identifying how many numbers it increases each time. It's about unpacking how the pattern actually works. What is happening here? Because even though this is simple, it is simple, but there is so much more going on that meets the eye, right? We identify that shared sides play a massive role in us
coming up with a formula that we can use if we were to look at patterns of a bigger number. So now what I want you to do, I want you to take this and try and find out how many sides are shared if we were to increase the number of hexagons to 30, okay? If you can go beyond that, even better. Good luck, and thank you for listening. Have a good night.